morning. This is Kasturi Day. Today I am going to continue with the discussion of water chapter according to ICSE syllabus class 8. So today I'll start with the chemical properties of water. So water, action on litmus, that is water, pure water is neutral to litmus. That means that it will not change any of the litmus paper, the color of any of the litmus paper. That is, neither it will change a blue litmus paper red, or nor it will change red litmus paper blue. Okay, then action of heat or electrolysis, that is, it is a highly stable compound. This water is a highly stable compound, but when heated above 2000 degrees centigrade, or when electric current is passed through it, then water decomposes into hydrogen and oxygen gas. Okay, so the equation will be like this: 2H2O when heated up to 2000 degrees centigrade, or electrolysis takes place, that is when electric current is passed through, it will decompose into 2H2 plus O2. Then action on water action of water on metals. Okay, so metals react with water, especially the very active metals. They react with water under different conditions to produce hydrogen. For example, potassium reacts with cold water, and this reaction is very fast. Okay, so to form 2KOH, that is potassium hydroxide, and hydrogen gas is liberated. Then sodium also reacts with cold water, that is, this reaction is also fast, but not as fast as potassium, but still it is very fast. Okay, it will form sodium hydroxide and hydrogen gas is liberated. Calcium reacts also with cold water, but this reaction is slow enough than potassium and sodium. So it forms calcium hydroxide and hydrogen is formed. Then magnesium reacts with steam, okay, forming magnesium oxide and hydrogen. Then iron, that is hot iron, is required for this reaction to take place, and steam is required. Okay, hot iron reacts with steam to form tri-iron tetroxide, and hydrogen is liberated, but this reaction is a reversible reaction. Okay, when conditions are reversed, it will again reverse back to the reactants, that is iron and water. These reactions indicate the reactive nature of the metals and enables us to arrange the metals on the basis of their reactivity. Okay, that is, the metals accordingly, the metals which are arranged according to the reactivity, that is in the metal series how they are arranged, they will react accordingly with the water. So first the potassium comes, so that reaction is very fast and it will react with cold water only. Then comes sodium. Sodium will react with also cold water, but the reaction is little bit slower than the potassium. Calcium will react with cold water, but the reaction will be slow. Again, magnesium will react with steam, not with cold water. Again, iron, that requires the metal should be hot as well as the steam is required for the reaction to take place, like this. Next is action on non-metals. So water reacts with coke, that is carbon. Coke is carbon. So water in the form of steam that reacts with coke to produce water gas. Okay, that's important, that this water gas is a very important industrial fuel. Red hot coke is required with the steam to form water gas, and the presence of 1000 degrees centigrade is required. Okay, then chlorine gas dissolves in water to produce chlorine water that contains hydrogen chloride acid and hydrochloric acid, and releases oxygen on exposure to sunlight. So sunlight is required for the action to take place, that is chlorine reacts with water to form hydrogen chloride or hydrochloric acid, you can say. In the presence of sunlight is required. Okay, then action on metallic oxides. Water dissolves metallic oxides, sodium hydroxide, potassium hydroxide, etc. to produce their metallic oxides. It reacts with metallic oxides to form metallic hydroxides, like alkalis are formed. Okay. Then actions on non-metallic oxides. Non-metallic oxides like carbon dioxide, sulfur dioxide, nitrogen dioxide, etc. These are non-metallic oxides. They react, they dissolve in water to produce acidic solutions. So metallic oxides, when they react with water, they form alkalis or hydroxides, and non-metallic oxides, when they react with water, they form acids. Okay. So like carbon dioxide reacting with water to form carbonic acid, sulfur dioxide reacting with water to form sulfurous acid. Okay. Next we come to tests for water. If it is a pure water, then it can be tested by its boiling point and freezing point. Boiling point, pure water will have 100 degrees centigrade as boiling point and 0 degrees centigrade as freezing point. So we can understand whether it's a pure water or any impurities are added to the water. Then with a few drops of water, anhydrous copper sulfate powder will change its color from white to blue. Okay, with a few drops of water, blue anhydrous cobalt chloride will change into pink color. Okay, so these are the tests of water. Next is we come to hard and soft water. So water on the basis of the lather formation, lather is when water is added to soap, we see some foamy substance form. That's a lather formation. So on the basis of this lather formation, we can differentiate water into soft water and hard water. If it easily forms lather with soap, then it's a soft water. If it is difficult or it is not forming lather, then it's a hard water. Okay, now hard water can be two types: temporary hard water and permanent hard water. Temporary hard water is caused due to the presence of bicarbonates in the water, like calcium bicarbonate, magnesium bicarbonate, and this can be removed. This temporary hardness can be removed if we boil the water. We can easily remove this temporary hardness. Okay, and permanent hardness occurs due to the presence of chlorides and sulfates of calcium and magnesium metal. Okay, and this can be removed by adding some chemicals to it, not by boiling. Okay, that has to be some chemical reaction to take place. But in temporary hardness, that was a physical method, by boiling. But in this permanent to remove permanent hardness, we need to add some chemical to it, that is sodium carbonate. We should add it, and then we can remove the permanent hardness of the water. See, next is disadvantages of hard water. Why hard water is very not fit for any purpose. Okay, why it is so? Why it causes problem to us? Because it is unfit for drinking, because it has certain impurities in it, that is due to the presence of calcium and magnesium salts of sulfate and chlorides of calcium and magnesium metal, and that produces some stomach upset, that causes some stomach upset if we drink those waters. It is not also fit for laundry purposes or for bathing, as it forms a sticky scum. Okay, which instead of lather, which wastes a soap, when we add soap to it for washing our clothes or for bathing, it will form a scum and not lather, and that's why what will happen, it will waste the soap. It is unfit for raising the steam in the boilers, as it forms a white deposit of salt which sticks to the side of the boilers. Scale or fur that reduces boiling space, damaging the container, so not good for boilers and industry. So when we boil this hard water in a boiler, what will happen, it will form a scale or fur around the inner side of the boiler, and that can damage the container. Okay, that requires more heat to be boiled, and that can damage the container, so it's not good for boiling and boilers and industries also. Then it is not fit for dyeing clothes. Okay, when we are coloring the clothes, okay, and then these water is used, that is hard waters are used, then what will happen, this color will tend to fade away very easily. Then it is not suitable for leather and textile industries also. It's not good for cooking also. So that's why these are the disadvantages of hard water. Next we come to how to remove the hardness of the water. First, temporary hardness temporary hardness is caused, we know that's caused due to the bicarbonates present in the water, in the groundwater, that is calcium hydrogen carbonate or magnesium hydrogen carbonate, or calcium bicarbonate or magnesium bicarbonate. This hardness can be removed by boiling the water. When we boil this calcium or magnesium bicarbonate, it will decompose to insoluble calcium carbonate or magnesium carbonate, which can be filtered out and will make the water soft. Okay. So when we add heat to this calcium carbonate and magnesium carbonate, it will form calcium carbonate, water and carbon dioxide will be liberated. In same case will happen to magnesium carbonate also. Next is permanent hardness. Permanent hardness is caused when groundwater dissolves certain minerals like calcium chloride, magnesium chloride, calcium sulfate or magnesium sulfate. This hardness can be removed by treating the water with washing soda, that is known as sodium carbonate. Okay, this washing soda will react with the chlorides or sulfates of calcium and magnesium to form their respective insoluble carbonates. And then when it is filtered out, then it will make the water soft. Like the reaction will be like this: calcium carbonate with sodium carbonate, that is calcium chloride with sodium carbonate, that is washing soda, will form calcium carbonate, insoluble calcium carbonate, and sodium chloride will be formed. Sodium chloride is soluble, but calcium carbonate is insoluble compound, so it will be filtered out. Then again, magnesium sulfate will react with sodium carbonate to form magnesium carbonate and sodium sulfate. Sodium sulfate is dissoluble, and so it will be dissolved in water, but magnesium carbonate is insoluble, and it will be filtered out, and that will make the water soft. The sodium chloride or sodium sulfate formed after the reaction does not affect the soap. It will easily form lather with the soap. Okay. Now, next topic will be water pollution. So I'll start in my next video. Please go through this. If you have any doubt, please do write in the comment box. Go through the text videos. Still, if you have any questions, any doubts, you can please write in the comment box, and as soon as as possible, I will give you the reply. Okay. If you are liking the videos, press the like button, share with your friends, and do subscribe to get the notification of my next video. Thank you for watching, and have a good day.